All right, everybody. Tonight we're going to talk about a very basic kinematics equation, but it's probably the most popular one. And depending upon the variables that you're given, you really need to address this differently in different situations. Okay, so what I'm going to do is I'm going to address each of the three situations using this equation: delta x equals v0t plus 1/2 at squared. And I'm going to start out here with different colors for each scenario, and I'm going to talk about each application of this. So the first application I'm going to give of this is, let's say that we're looking for time, okay? And let's say that I'm given a displacement. Let's say that I'm given an initial velocity. Let's say that I'm given an acceleration, and I'm looking for time. So basically, I'm given everything in this equation. And so let me just write over here. Let me just say that the acceleration, let's just say that's going to equal 5 meters per second squared. Let's say that the v initial is going to equal 20 meters per second. And let's just say that my displacement is going to equal, I don't know, let's just say it's going to move 10 meters. So let's say I am given these, okay? So I'm given these. And I want to find out what the time is using this. So find the time. So what is the time? Okay. Well, I'm going to go ahead and fill in these variables. So my displacement is my delta x. Let's say that's 10. My v initial is 20 times t plus 1/2 times 5 t squared. So if I went ahead and wanted to solve this, I basically would have to arrange everything on one side. So I'm going to arrange this in a standard quadratic form. So I'm going to leave everything here. So I'm going to have 5/2 t squared plus 20t minus 10 equals 0. And what I'm going to do is I'm going to just multiply everything through by a 2 just to get rid of that fraction. So 5t squared plus 40t minus 20 equals 0. So now I have to go ahead and I have to solve the quadratic. So in a standard quadratic equation, this is going to be a, this is going to be b, and this is going to be c, like this. So as I continue down here, I'm going to basically write up my quadratic equation. So I'm going to say t, the time, equals negative b plus or minus the square root of b squared minus 4ac over 2a. So that's my standard quadratic equation. And I'm going to have to just go ahead and plug in my variables now, right? So let me go ahead and do that. So if I'm looking for the time, I'm going to have time equals negative 40 plus or minus the square root of 40 squared minus 4 times 5 times negative 20, all of that over, let me make that all over 2a, which is 2 times 5. So let's see if we're even able to get a real answer out of this. I just made those numbers up. Negative 40, or a positive time, let's just say, equals plus or minus the square root of 40 squared, which is what? 1600, minus 4, negative 4 times 5 times negative 20. So I've got negative 20 times negative 20, which is plus 400, over 10. So, simplifying it one more step, I'm going to have negative 40 plus or minus the square root of 2,000, extend the page down here, all divided by 10. So anyway, we could further simplify this into saying negative 40 plus or minus what? Plus or minus, we could take out a 10 and we can take out a 2. So we would basically say that this is 20 root 5 over 10. And just to simplify that one more step here, I'm not trying to make this a math lesson on the quadratic equation, but I can simplify that a little bit further, right? I can say 4, I can even say, I can take it another step further. I can divide everything by what? Everything by 10, right? So let's just go ahead and do that. So let's just say if I divided everything by 10, I would basically have negative 4 plus or minus 2 root 5. Now, one of those answers gives me a positive answer, one of them gives me a negative answer, okay? So, I'm going to get two answers there. So I'm going to get negative 4 plus 2 root 5. And that's going to give me something slightly positive. It's not going to give me a dramatically positive number, but it's enough. It's enough to give us a positive answer here going forward. So we're going to get a slightly positive answer. Now, if I took negative 4 minus 2 root 5, I'm going to get a negative answer. So if I was using this question, I would get two answers. This one comes out to be about 0.472 seconds. And this one comes out to actually be negative 8.472 seconds. Well, let's just say, let's just do that, seconds here. And we see this in math sometimes, and sometimes teacher will just say, oh, just throw out the negative answer, it doesn't mean anything. Well, it kind of does mean something. The reason let me explain to you the physical reason why you get a negative answer. We're not going to take it, but we are going to throw this out, but this is the one that we care about in terms of time, because we're dealing with really only positive time when we're talking about a question. But let me explain to you why you would even get a negative answer there. There's actually a physical reason for that, and I'm going to be brief with this explanation. But it is an important point to talk about that. The reason is that when you have, let's say you have a projectile like this, and let's say that you had you're launching it off of like a building, right? Like this. And you want to know, let's just say, okay, you're saying, okay, I want to know basically when does it reach a height of, let me just make a certain height level here. Let's just say that represented a certain height or a certain displacement, let's just say, from the ground. So let's say that you want to know, you're launching something off of a building here, and you wanted to know when is it going to reach this displacement here. Let me just extend this across here. You want to know when is it going to reach this displacement down here. When is that going to happen? So your displacement is like this from here to here, let's just say. And you want to know, you're going to launch this thing like this, right? You want to know when is that going to happen. So here's your projectile. And I want to know when is it going to reach my displacement. What time is that going to give me? Well, okay. Well, we know that there's definitely going to be an elapsed time from the time that I launch it from the building, like this, okay? Across like this, all the way over to this point. And let's say that this is the ground right here. Maybe this is the ground. This is a person on the ground down here, and another person was on top of the building up here. Okay. And I just want to know how long is it going to take to drop that level. Well, we would just use kinematics to find that out. Let's say we get one positive answer and one negative answer. And the reason we would get two answers is the following. If you went back in time, which we didn't, right? We were going forward in time. But if you went back in time and you retraced that parabolic path, it would cross it back in time. If you went backwards in time, if that trajectory actually went backwards, you would go back in time. And that's why we get a negative answer sometimes with these quadratics. It's possible that they both can be positive also. Okay, so let me give you an example where you would have two positive answers. Two positive answers would be something like this. Let's say that I wanted to know, I'm launching from here, and I want to know, okay, how long does it take to reach a displacement of this? And let's say that the person is now, let's just say here, okay, and you want to know how long is it going to take to reach this displacement, and let's say the person throws it at a much steeper angle. It goes like this, and then it comes back down like this. Well, we know that it actually hit that displacement twice. So in that case, we would get one time here and one time here. So maybe, in a question like this, we would get one of the times would be 1 second, another time would be 4 seconds. I'm just rounding just to show you. But they both would be positive because they're going forward in time. In this case, if I threw it off a building, right, I'm going to get a negative time for this delta y because I would have had to go back in time and follow that trajectory back in time. So that's the physical meaning of a negative time when you're dealing with these quadratic equations, okay? Because it's accounting for the time that this occurs. It can happen twice in the positive, or it can happen one positive, one negative, or you could just get a scenario where you're never going to reach it. You could try to throw, like you could have a case where you're just never going to get an answer, because if you had a person down here, let's just say here's a person down here, right? And you're saying, okay, how long before I get to that height? But the person can't even make it to that height. You're not going to get any positive times, right? So this is an example where you would get, just to clarify again, like I got in this example, I got one positive time, I would get one negative time. In this case, we talked about over here, I would get a positive time here, a positive time here. In this case, I'm not going to get any real answers. It's just never going to happen, okay, because the person never made the height. So there is a physical reason why you're getting these positive and negative answers. I just don't want you to think, oh, well, it's negative, just throw it out. It doesn't mean anything. It's imaginary or whatever it is. No, they all have physical meanings in the real world in physics. And this is a big difference between physics and science versus mathematics. In physics and science, we really care about what's happening in the physical world and the meanings that these equations give something to the physical world. In math, we might just say, oh, just throw out the negative, without really telling you why you're throwing out the negative. Okay, so now the next example I want to give you is, let's just say that you have this equation, again, delta x equals v0t plus 1/2 at squared. And let me just give you another, this is a classic example where something starts from rest. Okay, so it starts from, let's just say, and it's given an acceleration of 10 meters per second squared. It starts from rest, and it's going to travel, let's just say it's going to travel, delta x is going to travel 20 meters. Okay, so you're given this. And again, we're going to ask you to find t here. What's the time? So this is the second scenario, and these are going to get easier and easier as I go down. You'll see it's pretty easy as we get down here. Okay, so this whole term just goes out. So we're basically just saying delta x equals 1/2 at squared. That's probably the most commonly used version of a kinematics application. We just say, what's the displacement? 1/2 at squared. Well, that's when you start from rest, right? So if I wanted to find the time, I would just go ahead and plug everything in. I would say, okay, 20 equals 1/2 times 10 times t squared. And I'm just going to go ahead and write t over here. So I'm going to say t squared, and this is going to be, let's just rewrite it here, 5t squared equals 20. So t squared equals what? T squared equals 4. And then t, remember we take a square root, always plus or minus, okay, plus or minus the square root of 4. So t is plus or minus 2. And of course we're just going to take the positive 2 from that, right? We talked about why we would even have a negative before. That's how you would solve it. That's really easy, right? I mean, there's no quadratic equation. There's nothing going on there. So that's that. That's that situation. Now let me go over the final one here. And a lot of times people overlook this one, and it's actually a really nice application when we're dealing with symmetry. So for example, let's just say that, let me just write out the equation again here. So this is scenario number 3. We're dealing with delta x displacement equals v0t plus 1/2 at squared. Okay. In this situation, I'm going to give you a displacement of 0. A displacement of 0. So that might seem kind of strange to you, but I'm going to explain to you how that works right now. And I'll give you an example. I'm going to use a delta y in this example, but let me just give you some parameters here. Let's just say it's a free fall question, okay? And let's just say, so we know my acceleration is negative 9.8. And let's say I'm throwing something straight up in the air. I'm going to throw it up at 10 meters per second. And I'm telling you, I'm going to use delta y here, it's going to return to its starting place. Delta y is going to be 0. Okay. So, again, we're going to find t. So let's go over to our equation. Well, this term, this delta y, is in this case going to drop to 0. So I'm going to have 0 equals v0t, which is 10, plus 1/2 times negative 9.8 times t squared. And let me just draw for you what that would look like. The reason we would have a delta y of 0, I'm using delta y here. Delta y is going to be 0. Because what I'm going to do is I'm going to throw something up. It's going to come all the way back, and I'm going to have a delta y of 0. Okay. And so in this case, it's pretty simple. Yeah, I'm just going to take the t, and I'm going to be able to factor it out. So I'm going to have 10. I'm going to multiply this here, minus 4.9 t squared. So I'm going to get 2 answers. So where is the delta y 0? Well, we know when you start the launch, it's at delta y is at 0 at the launch, right? So there's one of my answers, t equals 0. My other answer is basically saying 10 minus 4.9 t squared equals 0. Let me give you some more room down here. So I'm basically, again, going here, and I'm going to say t squared is going to equal negative 10 over negative 4.9. So that's approximately 5. I'm just going to take an approximate answer here. So I'm going to say, okay, t squared is approximately equal to 4. So t is approximately equal to plus or minus the square root of 4, which is, we know, is approximately equal to positive 2. I'm just going to take that positive value. So again, where is it 0? Okay, it's 0 at t equals 2, and it's 0 at t equals 0, and it's 0 at t equals 2. So my delta y started from here, it went to a max height, it came back down, and we got all kinds of interesting symmetry here too. When it's going straight up and it comes straight down, we know it's symmetrical, so look at that. We would know that our max height would occur at t equals 1. So, just to summarize here, let me go back to the beginning, because I know this was long, a little bit longer than I wanted it to be in terms of length, but the first one we went over was, we talked about this equation when you have an acceleration, an initial velocity, and a displacement. And when you have that situation, you're either going to have to factor it, or you're going to have to use the quadratic equation. In this case, we went ahead and used the quadratic equation. and we got two answers. One was positive, one was negative. And I talked about why do we get positive and negative answers? And the answer is that if you throw something off a building, let's just say, and it hits a certain delta y, you're going to get one positive answer. But if you went back in time, you could get the negative delta. You could get the delta y over here with the negative time, or you can get two positive times. If your objective is this delta y, it hits it once here on the way up, it hits it here on the way down, or you may never hit that delta y. So that's the physical meaning behind that. And the next one we talked about was simply if you start from rest, right? This is probably the simplest case. Delta x is 1/2 at squared. How far did you go? 1/2 at squared. Okay. So in this case, I was just using something along the ground. I used acceleration of 10. My delta x was 20. How long did that take? And so when we went ahead and plugged it in, we had 20 equals 1/2 times 10. And we ended up with 5t squared equals 20, t squared equals 4, t is plus or minus the square root of 4, and we're going to just take that positive answer. On our final answer, I gave you the scenario where this delta x could be 0. So in that case, let's say we threw something up and it landed back at the same spot that it started with, I would have a delta y of 0. And so we end up with this scenario, 0 equals, in this case we had negative 9.8. It's thrown up with an initial velocity of positive 10, and the delta y is going to come back to where it started. Okay, so in that case, we would just say delta y is 0, and we say 10t plus 1/2 times negative 9.8 times t squared. And you factor out a t, okay, and then we know that when we factor something out, there's two solutions. T equals 0 right here. Okay, t was at 0 because we know that delta y occurred right at the start. It was at 0 at the start, right? Okay, and then we went ahead and we solved for the other term, subtracted the 10 divided by 4.9, which is about 5. So that ended up with t squared is approximately 4. So t is approximately plus or minus root 4, which is approximately 2. So it's at 0 here and 2 seconds later. And I just kind of threw this in here that we knew that it hit the max height at t equals 1 because we have symmetry always in these when it's going straight up and it's returning, that it took exactly the same amount of time up as it took to reach the ground. All right, that's all I got for you tonight on this video. Thanks for watching, and I'll talk to you soon.